All right, so today we're talking about how to use the midpoint and distance formulas. So if you go to Google Classroom, you'll find this document in today's assignment, and you're welcome to open it up and print it out and write on it. If you have a stylus and can write on it on screen, great. If you'd rather just take a piece of paper out and write your answers down, show your work there, that's fine as well. So first of all, we have to define a segment bisector. So we've been talking about the midpoint of 2 points and the distance between 2 points. A segment bisector has the prefix bi meaning 2 and sector meaning cut or sectors. A segment bisector is a point, line, segment, ray, or plane that separates or cuts a segment into 2 equal parts. Bisector. 2 parts. So we have a segment bisector for segment ST. Notice the segment mark, that means it's a segment, not a line. So here's segment ST, and notice that it has a tick mark here and a tick mark here. That's how our book and all of our assignments are going to show you that those 2 pieces are equal. So first of all, we want to know what is cutting that segment into 2 equal parts. So we could name a point. You could write point M, because M is the point that cuts it into 2 equal parts. In fact, M is the midpoint of that segment. Or you could say that segment MC, or we can use our symbolism, MC, with the segment mark on top, or we could also call it segment CM. All 3 are perfectly acceptable answers for this. So then we want to know, what is ST? Well, notice the absence of the symbol here. When we have no symbol on top of 2 letters, 2 capital letters, that is a shorthand for saying the distance between points S and T. So that's a lot easier to write that symbolism or lack of symbolism to tell us that we want to find the distance between those 2 points than it is to have to write that out each time. So mathematicians are all about symbolism. We try to make things as simple as possible and as concise as possible. This is our way of saying the distance between points S and T. So we check out our segment. So our segment goes from S through M to T, and M is the midpoint. It's a bisector. It's cutting it in exactly in half. So if this portion of segment SM is 18 and 2/10, then M to T should also be 18 and 2/10. So if I need to know the distance all the way across from point S to point T, I either need to take 18.2 and add it to 18.2, or we need to take 18.2 times 2. So we get a good old 36 and 4/100, and so that is our answer, 36 and 4/100. All right, so here's the other part of example 1. Let's change my pen color here and do the next one in a different color. Now we want to find the distance between S and T once again, only this time we're given 2 algebraic quantities. So S to T is split into 2 equal parts by point M, or our bisector, which could be written as ray MA, because the ray is starting at M and heading in the direction of A, or it could be written as segment MA, or it could be written as segment AM. But notice we have to use that symbol above it, or we're saying the distance between A and M, and that doesn't make sense that a bisector could be a distance between something. And then also point M can work as well. So since these 2 segments are congruent or are equal, then that means that the 6x minus 7 has to be equal to the 4x minus 3. So suddenly you see the difference between algebra and geometry. In geometry, we have to know properties of things. We have to know what a bisector is. We have to know what a midpoint is. And then we can use the things that we know to create the algebraic statement. Whereas in algebra, we give you a whole bunch of problems and just ask you to solve them. So geometry is more difficult in the fact that we have to know something about it before we can set up the equation, then solve the equation, and then answer the question. So if we were going to solve this algebraic equation, that means that we're likely going to decide to subtract 4x from both sides because we have a positive 4x on the right side and we may want to bring it to the left. So 6x minus 4x is 2x. And if we are moving our letters to the left or our variables to the left, then we probably want to move our numbers to the right. And if we're subtracting 7 from the left-hand side, we're going to add 7 to both cases, or both sides, to get our answer on, or our number on the right-hand side. So a positive 7 minus 3 is a positive 4. And then we're going to divide by 2 because x is being multiplied by 2. And the inverse operation for multiplication is division. And so x is going to be equal to 2. However, we have to ask ourselves, did we solve this or answer this question? Well, this is asking for the distance between s and t. It didn't ask us what x is. It wants to know how far is it from s to t. So to find out how far it is from s to t, we have to plug that 2 back in. 6 times 2 is 12, minus 7 is going to be 5. So if the distance from s to m is 5 and m is the midpoint or the bisector, then the other portion, m to t, had better be 5 as well. And you could plug 2 back in for the x and see if you get 5 on the other side. So half the distance is 5, the other half the distance is 5 for a total distance of 10. So we've finished our example 1 in this box. That means that you have 2 more problems just like them to do right below. So let me move on to the midpoint formula. So 2 days ago we learned the midpoint formula, we derived it, and there's 2 ways of thinking about it. You can ask yourself, what is halfway between the x's and the y's? Or you can learn the midpoint formula, which means that we're getting a point that's midway in between, that's halfway in between. So we take our good old big parentheses and we're going to take an x2 plus x1 divided by 2 and a y2 plus y1 divided by 2. X's with x's, y's with y's. We're adding this time. With slope and distance formula, we subtract, but with this one, we add, because we're averaging the 2 points, the 2 coordinates, to find out what's in the middle. So you could also simply write, we add the x's over 2, add the y's over 2, if that helps you remember. So use whatever makes sense in your brain. So on example 2, again, we have a box here, so this is when we'll work together. We have the endpoints of segment PQ are negative 8, 7 and 7, 3. And we're supposed to find the coordinates of the midpoint. So you can ask yourself on a number line, what's halfway between negative 8 and 7? And what's halfway between 7 and 3? X's with x's and y's with y's. And that can help you get an answer. Halfway between negative 8 and 7 on a number line, well, if it was negative 7 and 7, it would be 0. But it's pulling it more toward that left-hand side, the negative part. So it would be a negative 1/2. But if you can't visualize that in your head, we can try something else. And halfway between 7 and 3 is, well, they're odd numbers, so it would be 5. But if that doesn't work for you, add your x's, negative 8 plus 7, and divide by 2. Add your y's, 7 plus 3, and divide it by 2. What is negative 8 and 7? One's positive, one's negative, so we subtract them and give them the larger absolute value sign. So a negative 1/2. And 7 plus 3 is 10. 10 divided by 2 is 5. So you can write your answer as negative 1/2, 5, or you can write your answer as negative 5/10, 5. Does not matter. They're the same thing. So now you have 4 problems just like that to work on I want you to do 4 midpoint problems and make sure you show your work somehow, whether you're drawing a number line so you can find halfway between those points, or whether you are adding the x's and dividing by 2 and adding the y's and dividing by 2. Our next portion talks about segment addition. And the segment addition postulate says that if we have a point B that is between points A and C, might be closer to one than the other, it might be the midpoint, we don't know, then the distance between A and B plus the distance between B and C is going to be equal to the distance between A and C. So that makes sense. This piece right here plus this piece right here had better make this whole thing, or something's wrong. If we have a 12-inch piece of wood and we have a 4-inch piece that we cut out, that 4 inches plus 8 more inches had better equal that whole piece of wood that is 12 inches. So that's the segment addition postulate. So in this case, 3 from the number line 0 to 3 plus 3 to 8 is 5. Altogether, 1, 2, 3, 4, 5, they add up to 8. And from -4 to 3 is a total of 7. And from 3 to 7 is a total of 4. So from -4 all the way to 7 had better be 11. That's the segment addition postulate. Postulate just means that it's something that we accept without having to prove it. It's like the sky is blue, water's wet, grass is green. So we don't ever say that we'll prove that the grass is green. Of course, if it's dry, it's going to be brown, but you get the idea. All right, so here's our example 3. If I ask you to find the distance between, notice there's no symbols here, it's not a segment or ray or a line, the distance between x and z, and we see that between x and y is 14 and between y and z is 27, what do you think we're going to do here? Well, we want to get this whole distance, so we want to add the 14 and the 27. And we should get the distance between x and z is 41. In our example 4, we want to find the distance between C and D. Well, C and D is this little piece right here. So if this whole distance between B and D is 25, and the distance between B and C is a lovely 19, then that means that we probably need to subtract the 25 minus the 19 to get 6, and that's how long the distance between C and D should be. So you have 2 more problems just like this, number 7 and 8, to practice these skills. And then a question to answer for number 9. Some critical thinking here. Then we lastly want to talk about the distance formula. So yesterday we worked on the distance formula and we found out where it comes from. So if we have a segment xy, x1, y1, connected to x2, y2, and we want to find the distance between those 2 points, then we have to think about it as being a right triangle. So we need to know what is the horizontal distance, and so what's the difference between the x's, and what is the vertical distance, the distance between the y's, and then we can use Pythagorean's theorem to say a squared plus b squared equals c squared, or our distance. But because it's equal to c squared, we can simplify it and say I need to take the square root when it's all said and done. So you can think of this as a Pythagorean theorem problem. Or you can say that I'm going to use the big distance formula for any x sub 1, y sub 1, and x sub 2, y sub 2. The distance is 1 big giant square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now remember, up here with midpoint formula, we added and divided by 2. With distance formula, we subtract square, and then we add in the middle. So order of operations is important here. We have to do what's in parentheses first, then square them, and then add them, and then take the square root. So, two ways of approaching it. Also have 4 problems to do here, show some semblance of work. I'm looking for a minimum of this much work. If you can ask yourself what's the distance between 3 and 7, or 13 and 7, and you can mentally think that's 6, and I'm squaring it to get 36, and the distance between 2 and 10 is 8, 8 squared is 64, I need to see at least this much work in our final answer. But you can certainly use that full distance formula. It's great practice and it will serve you well. We're going to use this formula and the midpoint formula every chapter except for maybe chapter 2 this year. So it's really important that you know them, that you remember them, that you embrace them, and that you can do them consistently well so I don't have to stop and teach it over and over again. All right, thank you for watching.